Hello everyone, and thank you for joining us for the webinar today. My name is Ben Hutchins and I am part of the marketing team here at Innovise. The webinar today will showcase the path to optimizing water network resilience. As we move through the slides, if you have any questions, please type them into the question box located in the right corner of your GoToWebinar interface. Your expert for the webinar today is Rebecca Wiley. Rebecca joined Innovise 2 years ago, having previously worked at Atkins. She is one of our solutions engineers and specializes in the water distribution product set. She helps provide technical information about the products and how you can fully utilize your software. I'll now hand over to Rebecca to take things away. Over to you, Rebecca.
Thanks very much, Ben, and welcome everyone to this morning's session. So what we're going to be covering in today's session, we're going to look through some of the applications for looking at risk and resilience using InfoXWS Pro, how some of the functionality and the engine enhancements we've had over the past few years help make that more accurate and give you more detailed insight. We'll be touching on a short video going through the new scenario manager that we've added into InfoXWS Pro and how that can really bring what we discussed before that and hopefully really enhance your project work. And then briefly just touch on some case studies from a customer who's used these for their business plans. So we started here in the last webinar and just to highlight really some of the ways that modelling can help you do your work, whether that be for a utility or a consultant. So last time we looked at leakage at the top and today looking at resilience, a lot of these will be touched upon. A lot of these ensure that our network is resilient to provide adequate water supply and water quality. So yeah, a lot of these will be touching on today. So why are we here and why do we care? So we have aging infrastructure, which we all know increases in demand. That's demand growth, but also demand on the requirements of the customer and what they expect from their water supply. We can interact now more with utilities, give our opinion, how they're coping with an incident. That can all be seen on Twitter and Facebook. And so how we minimize that and how we operate utilities in the most efficient way is really important. And so one of the ways we can look at that is assessing our critical infrastructure and then making that as resilient as possible. So we're affecting the least number of people or the most critical assets to us as a society. So the first thing to touch on, which was something that was brought to light off the back of Grenfell, is really looking at the FIFO requirements that we have within our network. Not just ensuring that we have resilience for the network and that the network is resilient, but we then have the resilience to support that function for the fire service. So the tools in there enable you to test your fire flow and hydrant testing based on your requirements, and that may vary throughout your network, and those can be totally custom inputted. The results can then be seen graphically, seen which hydrants fail those tests, and then planned works and projects can be done around that to ensure that the network is potentially changed or enhanced and that those fire flow requirements are met. And so this can be a task that is undertaken as a one-off task. So if utilities think that they potentially have had a lot of growth in an area recently, they may want to do this assessment. Or if you're looking at a project, if you are looking at putting in increased demand, running this assessment at the beginning of your work, doing your design and your optioneering, and then checking this again at the end can ensure that you've made no detriment to the network, and that it is still providing the level of service that it should to people, but as well to this function of society. So again, this is the fire flow and hydrant testing, which again available with all of your licenses. Moving on from that, another full network assessment is assessing critical pipes. So we have the tool, the critical link analysis, which automates the testing and reporting of the effects of the failure of pipes. So here we're looking at maybe looking if a pipe was to be out of service, either at a burst or it had been isolated as part of some planned works or some unplanned works. How would that affect your customers? How many customers would be affected? Which of those customers is a key customer, either a hospital or a school, or however that's defined for you? To then grade your pipes on how critical they are for supply to be maintained to the most number of people. So from this, every pipe gets a grade. The grading system can be determined by you as an organisation, whether that be on number of customers, number of key customers, change in pressure, change in demand. And you're able to look at each of those potential scenarios of that pipe closure, exactly which customers would be affected. So we get a summary grid, much like the one at the top, looking at a selection of pipe that we've selected to test this. And then if we click on any one of those, we would get the box at the bottom where we can see each individual unique customer reference, the pressure that they receive, how long they receive that for, and what their lowest pressure will be. So we can get a full network assessment of our most critical pipes, and this will be one of the case studies we'll touch on towards the end. But it can really help identify those pipes which are necessary potentially for resilience work or for rehabilitation schemes. And while the two techniques we've just touched on are specific applications, so looking at testing fire flow and if that meets the requirements and where that is, and then the critical pipes, we have a function called the generalized multi-run, which is as vague as the name sounds, and is a wizard within WS Pro, which helps you define different scenarios for different assets. And those can be distributed to multiple computers so that you can get through as many simulations and scenarios as possible. And you can be outputting specific results for your needs. So really it is on any asset, on any parameter. And so within the tool you could specify, for example, a selection of valves and that they are going to be open in peak demand time, and what that would mean for the effects on customers for pressure, or looking at flow reversals and water quality. You could select a range of pumps and look at if they were to be shut down, either all at the same time or individually, and how that would affect transients or age of water, for example. And we can look at that for the consequence of a burst. So if a selection of those key pipes that you potentially identified during the critical link analysis, if those were to burst, be burst for 6 hours at peak time, how would that affect a whole host of parameters that are important to you? So pressure or water quality or whatever that might be. So any parameter that you can think of that you'd like to do an assessment of, and this can be done on your whole network, or it can be done on a selection of pipes or assets, or potentially a DMA or a couple of DMAs. And so really as much as however you want that information and whatever output you want, this wizard can really help you do that through the use of SQLs to help you define the parameters that you want to see. And how we can ensure that these results are reliable is our proprietary engine that's in WS Pro has enabled us to develop it to show more realistic scenarios. So whether that be an isolated network because of a pipe burst or a pump shut-off, we can use the drain down and recharge tools, which allow that accurate representation of the network draining down, which is the green line you can see on the GIF on the screen. Whereas in other applications, you'd have the blue line where the pressure would drop instantly for the whole of the downstream network. And it would appear that those customers are completely isolated for the full duration. This is, of course, not true. There is some water still in the pipes. There is some pressure still within the pipes. And so we can see that and more accurately report which customers are affected. The analysis also goes down to a customer point. So the analysis, like with the critical link analysis, we can assess the duration of outage or the duration below pressure or the age of water from the water quality analysis for each individual customer. And so the analysis, when we're doing that on a full scale for a full network, can ensure that we are being resilient for the customer and not just the assets. So here is an example here looking at the results of well, this is a source well cut off, but a pump shut down from a water source with and without this application, and how the results and what you get from your analysis can be very different. So we have on the left-hand side without the drain down functionality of InfoWorks WS Pro, where as soon as the well is shut off at 7:05, all the customers are red and they are all below 0 meters pressure. So we have 2,940 below 0. Whereas actually with the drain down and with looking at the distance from the source, the pressure and the customer demand, we can see that with the functionality of InfoWorks WS Pro, we have 1,645 that are below 0. So quite a large difference. And if this reporting was going to be done for incident reporting, going to a regulator, that can make a massive difference in fine against that target. So this all helps with ensuring that the work that we're doing is as accurate as possible. And how we can do this. So all of the things that we've looked at for resilience are on a full, can be done on a full network. So we're not just having to choose specific pipes or specific hydrants we want to do fire flow tests on. You can select your whole network with no need to make it smaller or remove pipes or skeletonize it. You could select the whole network or all of your assets and run this analysis. So you're not missing anything. You're not missing any type of valve that could be important to the assessments that you're doing. And we're able to do this because of the technology allows us to spread out the load of running these simulations. So we can run simulations on our laptops and our computers, but we can also send those simulations to other computers, supercomputers, a server, and to many computers as well. So we can see here we've got a generalized multi-run, got 800 tests that it's doing on 800 assets, and we can see here, just play it again, we can see here what each group of tests, and they are working in parallel. They are simulating in parallel on a whole range of different machines. So the run on column showing us there where it's being ran, and we can see that that's how we can do these assessments much quicker. We're not having to wait days for results or weeks for results. These assessments can be done more frequently, and they can really be done to check that ongoing resilience, not just looking at it for business plans and for investment at a one-off point, but multiple times a year or once a year or whatever that might be to help produce a plan of investment that can be done, and there is a very quick way of doing that. So one thing that can enhance all this even further is the new functionality within InfoWorks WS Pro, the Scenario Manager. So the functionality and the tools that we've talked about so far have been in WS Pro for many years and have been used to a greater or lesser extent by a lot of customers and clients. The Scenario Manager is a new function that was added into 2021.8, so a few months ago. So some of you may, if you have the latest release, have got this in your software. Others, you are have the ability to upgrade, and any new users, you would get this functionality straight away. So what this allows you to do is plan and have lots of different scenarios for planning, for future scenarios, for what-if scenarios, for design scenarios, and to keep those separate from your base model. So instead of having to try your scenarios for pump sizing or pipe sizing or a PRV set points, instead of having to create multiple base models, you create multiple scenarios which are associated with that base model. You can then test them individually and look at the results, and when you have your optimal design, you have the ability to bring that and make that your base model going forward. So if you're doing some design work, you can make scenarios and do that, and then before you, as a consultant, you pass that back to a utility, you could make that the base model, and the history and the version control of the model would move forward. So some of the ways that we think it will enhance workflows, looking at design horizons. So if we looking at demand for the next 5, 10, 15 years, different areas of the network that's going to be, that would be a great use for this. Looking at pipe rehabilitation schemes, so whether that be looking at pipe sizes, but also for where the best way and areas to do that design work throughout the system to ensure resilience as well as customer supply. We can try different options for pump usage, but again, as I said, you could try different set points for PRVs or valve settings to try and get the most optimal way to operate your network, and the same for future planning works and any kind of design. So if we're looking at adding in a new reservoir or a new pumping set, what are the different options, and then they can be easily assessed. So I'm going to go through a video now and briefly take you through this. It is just a video at this point, but there are knowledge base articles on the support portal, and there's another blog on the website, and of course contact us if you would like more information. Okay, so here we are in InfoWorks WS Pro. Again, as I said, it's just a new function as you open InfoWorks WS Pro. We have this toolbar at the top here, which would be a new toolbar for you. And here we can click on creating a new scenario. So we're going to be creating a new scenario on a new development. And now we can add a node to represent some new development and some new demand, and the pipe to connect that to the existing network. So we can see at the top there, we're doing this in the new development scenario. So we can see in the base that that network is not there, and that was drawn in our new development scenario. We can then select the node at the end and add a demand to represent this future demand. So here we're adding 12 properties at 400 litres property per day consumption. And then we could create a new scenario with an alternative demand of whatever that would be. And we can copy the existing scenario. So here we're going to copy that new development scenario. So it brings in everything that was part of that scenario, including this added demand. And we're changing that from 12 to 16 properties. At any point, you might want to manage your scenarios. So you could delete scenarios, you can rename them. And if we look at the manage scenario box, you get your full list of it, much like the commit box that we have now. So yeah, you can select two and look at the differences. Here we can see that we just had that node demand added to that new node, and that's our only difference between the two there. The most important thing is this reintegrate button, which could be your desired design, and that's what you want to be reintegrated into your base to become a new version of your base model. And so that would become a new version in your commit history of that base model. In the objects column, we can see that the base had nearly 8,000 objects. The new scenarios, they really only keep the changes. So where it says 2, there's not 2 objects in the network. There is 2 changes made compared to that base model. So you're not having a great data store. It's not making loads of duplicates of your model. It's trying to be as efficient as possible. So as with all in the commit history, you always have a date and timestamp in there as well, so you can always see who made that change as well. So you can select some objects in one of your scenarios and you could delete them as we have here. So we've deleted that network from the alternative scenario, and we can see that they're held there as ghost objects. They're kind of held there but not accessed by that alternative scenario. But you could see where that network is currently in your base, in your current model, and you can restore those objects at any time. So those excluded objects, and we can also view those in a grid. You could select some of them perhaps, and you could reintegrate those back into your model. So the 4 nodes that we've just selected there would come back into your model, or we can bring all those excluded objects back, which we have now. So when we save it, we'll save those scenarios and commit that to enable us to do a simulation and look at the difference between those different design horizons. So if we update to the latest commit history, we now have this new toolbar for the scenarios in the Run dialog, which gives you the option to select all of the scenarios to do a simulation, or you could just select a few to just run the alternative development, for example. But you could run them all, which is what we're going to do. And so it's told us that we're going to run 3 scenarios, and we can see that in the Run log at the bottom here. We can see it's in process, and then we can see the 3 different scenarios, and we have this new extra column in the job window to show you the scenarios as they move through. So while they're doing that, just highlight that scenarios can be used with SQLs. So if you want to update specific scenarios, you have the ability to do that using the in scenario syntax. Loads more information about the syntaxes in the help if that's something that you try and do. The SQL can also help you generate the scenarios, which can really help with the speeding up the optimization of some of those workflows that I spoke about earlier. So we have this length of pipe here, and we're looking at the different diameters that this pipe could be, so 100 through to 300, and it will loop through and it will be creating a new scenario with that new diameter for each. So then if we look in those scenarios, we can see that it's made those scenarios. And looking at a long section, as we flick through, we can see that diameter change. So it has changed that those selected pipes to those scenarios. So this is really key in helping you optimize your network. Different tools like that can really speed up the process. It's not as laborious as someone having to click and manually change different pipe diameters. Can be done really quickly. And here we're looking at comparing the alternative results. So comparing the different demand profiles. So the two scenarios that we set up and the flow that they have down that pipe. So that's just a very quick run through of some of the things that it does. It's by no means touched on everything and every workflow, but hopefully you can see that it enables you to create scenarios and try different things within the network, but that can also be automated to help improve your optimization of designing and planning different assets, like the pipe diameters in this instance here. And so just to touch on some of what we've talked about was used by Bristol Water to help inform their business plan for their price reviews. So they looked at the critical link analysis, one of the first techniques we looked at for identifying critical assets. They did this on their full wide company area. So they looked at the mains which affect the greatest number of people, and so where the network could be enhanced and where money and investment could be best spent to ensure that that resilience was there. And so one of the outputs is the picture you can see on the left there. So a full network view of the different pipes that affect different ranges of population. So ones that affect greater than 25,000 population. Studies were then looked at of how they could ensure that there was parallel pipes, different boundary valves that could be open and closed to deal with that if that problem arose. But as well, just being aware of that from a full holistic point of view before these things happen. Tags and information can then be added to your asset registry to say that if you had an incident on this pipe or it was involved in an unplanned incident, what level of people and what different departments would need to be involved, because it is affecting large numbers of people. There are multiple reservoirs downstream and other things like that. So it's a great assessment to it to ensure you have a great view of your network. And then they also looked at what they called the reverse trace analysis. So this is looking at water quality contacts. So people that are called in about discoloured water, and then looking at kind of upstream tracing, common pipes that were involved in the majority of those upstream traces, and did analysis to see what types of pipes they were, when they were laid, and the kinds of diameters they were. From data from the past 5 years to identify those common pipes often involved in the water quality incidents. So this helped them determine the pipes for replacement or for lining. And this gave them much more transparent evidence for doing those schemes and where those priority schemes were. So that's all I've got to touch on this morning. So hopefully we've been through some of those techniques that we have in InfoWorks Pro to help with your resilience of full network analysis, and then the scenario manager, which will really help enhance and speed up some of those processes for you. So I'll hand back to Ben.
Excellent. Thank you very much, Rebecca. If you ask a question, we promise to get in contact with an answer for you. We would also like to encourage your ideas for future webinars and case studies. If you have any thoughts, get in touch with Rebecca at rebecca.wiley@inivise.com. Next week, we have 2 exciting webinars for you. Firstly, a 30-minute tea break talk on Tuesday, the 5th of October, where we'll be joined by Kevin Enfinger, Product Manager at ADS Environmental Services, to investigate the impact COVID has had on sewer flows. Then on Thursday, we're delighted to be joined by the Right Honourable Philip Dunn MP for an hour-long water talk focusing on reducing sewage pollution. The links for these webinars are in the chat box, so please join us if you can. Please do visit our website for more information about our virtual training courses, and take a moment to complete the quick survey that follows this webinar to receive a certificate you can use for proof of professional development. Lastly, a big thank you for joining us today. We hope you have a great day, everyone.